Hello and welcome to ISC class 11 maths tutorial. The topic is geometric progression, GP. Before we start, आइए आपको एक शायर की कुछ लाइन सुनाता हूँ. शायर कहता है, यहाँ गुनाह हवा के छुपाए जाते हैं, यहाँ गुनाह हवा के छुपाए जाते हैं, चराग खुद नहीं बुझते बुझाए जाते हैं, चराग खुद नहीं बुझते बुझाए जाते हैं. ये कैसा कर्ज है नफरत का कम नहीं होता, ये कैसा कर्ज है नफरत का कम नहीं होता, ये बढ़ता जाता है जितना चुकाए जाते हैं, ये बढ़ता जाता है जितना चुकाए जाते हैं. Thank you. Okay. The topic is GP, geometric progression. In the arithmetic progression, we saw that the difference between any two consecutive terms is a constant. See the difference between the two, the arithmetic progression and the geometric progression. See the comparative study that will help you to understand. In arithmetic progression, we saw that the difference between any two consecutive terms is a constant. Alright. Or you can say that in a sequence, if the difference between any two consecutive terms is a constant, then that sequence is an arithmetic progression, and that constant is called the common difference. Alright. If you remember, we did like this: an plus 1 minus an, and this is equal to a constant, we call it p. Alright, so the difference between any two consecutive terms of a sequence is a constant. We are calling that constant as d. Then it is an arithmetic progression, and we call this d as the common difference. Now see here, what is the difference? See the small change. Here we talk about the ratio between the two consecutive terms. An plus 1 minus an, difference, AP. Here ratio, then it is GP, geometric progression. So if in a sequence the ratio an plus 1 upon an, the ratio between any two consecutive terms is a constant, then that sequence is called a geometric progression. Alright, for example here, one term is an, the next term, consecutive term, is an plus 1. So an plus 1 upon an is a constant, and that constant we are calling here r. Alright, so this is the geometric progression because the ratio between any two consecutive terms is a constant, and this constant we call here, in the case of geometric progression, we call this common ratio. Here we call it common difference, d, and here we are calling this r as common ratio. Got it? Clear? Fine. So this is geometric progression, very easy. Alright. Now we will find out, I'll give you the formula to write down the nth term of a GP. the formula is now I'm deleting this, I'm dropping this because this is for arithmetic progression. Alright. For GP, the nth term Tn, formula is this Tn. Tn is equal to A R raised to the power n minus 1. This is the nth term of a geometric progression. With the help of this formula, like in the case of arithmetic progression, if you remember the formula, we discussed the formula. We studied the formula Tn is equal to A plus n minus 1 into D. And here it is Tn is equal to A R raised to the power n minus 1, where A is the first term of the geometric progression. Okay, now let's solve few questions from GP. So first question we are taking 2, 4, 8. This is the GP given. We have to find out the 7th term of this GP. That means T7 we have to find out. T7. This is the question. T7 we have to find out. Okay, T7. A is how much? A is equal to 2. First term is 2 given. A is equal to 2. Now R we need to find out. So R, how shall we find out R? Let me find out R. R is what? The ratio between any two consecutive terms. So either this upon this or this upon this. Consecutive term, not this and this. They are not the consecutive terms. Consecutive terms means one after the other, right? So either you take 8 upon 4, which is 2, or you take 4 upon 2, which is again 2. Any 2. So if you take 4 upon 2, 4 divided by 2, and this gives you 2. So common ratio is 2. Here also if you take 8 and 4, then also you will get 2. See, 8 upon 4, 4 to the 8, so you will get 2. Any two consecutive terms you will get 2. So this is R. Now you have to find out T7. So let's first write down the formula Tn. So write in a systematic way, so write down. We know that, or since Tn is equal to A R raised to the power n minus 1. This is the formula. Therefore T7 is equal to A means 2. R means again 2. R means again 2. A R raised to the power n minus 1. N is 7. Where is n? N is 7, no? T7, so n is equal to 7. That also you can write down. N is equal to 7. Alright? So where to write down n? Anyway, write down n is equal to 7. N is equal to 7. So 7 minus 1. Now this gives you, this is equal to, or you can write down again T7 is equal to 2 into 2 raised to the power 6. 2 into 2 raised to the power 6. Is that fine? 2 into 2 raised to the power 6. 7 minus 1 is 6. This gives you total, gives you 2 raised to the power 7. 2 raised to the power 7. If you simplify this, you will get 2, 7 times, right? So 2 to the 4 to the 8 to the 16, and then 2 to the 4 to the 8. So 16, 8 is 128. How much? 2 to the 4 to the 8 to the 16. 4 2's we are taking here 16. And then 3 2's remaining, 2 to the 4 to the 8. And this gives you how much? 128. So 128 is the answer. 128 is the answer. Is that fine? This is your answer. Wait, 1 minute, I write down answer. This is your answer. So T7 is 128. How is it? Easy? Okay. Now next question. Next question. You can write down directly. If you can multiply 2 7 times, you can write down. After this, you can write down 128. Alright. I didn't do any rough work here only. I have taken 4 2's together. So 2 2s are 4, 2s are 8, 2s are 16, and 3 2's. 2 2s are 4, 2s are 8, and then I multiplied. If you know the table of 16, so very easily you can write down 16 is 8 is 128. Table is important. One should know the table up to 20 at least. See how it is helping you here. You don't have to actually multiply. You can write down directly 16, 8 is 128. Okay, fine. Next question. Next question is, again we are finding out, let's do one more question where we find out Tn, T5, T6, T7, whatever. So the next question is, find the nth term. That means Tn only you have to find out, and the GP is given this. Find the nth term of the following GP. That's the question. Find the nth term of the following GP. So, and the GP is 15 upon 8. This is your question number 2. Second question. 15 upon 8. And 3 upon 8. So you get 3 upon 8, and then I guess 3 upon 40. Let me check. 3 upon 40 and so on. Yeah, this is the GP, and we have to find out Tn, nth term, not 7, 8, 9, not that. Nth term we have to find out. Tn. That means the answer will come in terms of n. Alright, okay, so your question is find out Tn. Tn is equal to question mark. A is how much? Let's write down A. A is how much? 15 upon 8. Is that fine? No dispute? Clear? D, R is how much? Not D, sorry. D we talk in the case of arithmetic progression. Here we call it R, common ratio. So R is how much? R is equal to how much? R is equal to second term upon first term, or the third term upon second term. Anyone you can take. You can check anyone. So I am taking the second upon first. So 3 upon 8 divided by 15 upon 8. And this gives you 3 upon 8 into 8 upon 15. Is this? 8 cancel, this 8 cancel. 3 5s are 15, 3 1s are 3, so 1 upon 5 you are getting. You are getting 1 upon 5. So R you got 1 upon 5. If you take this upon this, then also you will get 1 upon 5. You can check it. You can check somewhere. This upon this, again you are getting 1 upon 5. So we got the first term A, we got the common ratio R. Now we can use the formula. The formula is since Tn is equal to A R raised to the power n minus 1, therefore Tn only we are finding out. Therefore Tn is equal to A. A means how much? 15 upon 8. Now R, what is R? R is 1 over 5 whole raised to the power n minus 1. Alright, Now this is your answer. Either you leave here or you can do one thing. See here you are getting 1 5. 3 5s are 15. So that 5 you can bring with this. Till here also it's okay, but I think we can write down one more step. We can write down this 3 5s are 15. 3 into 5. So 3 upon 8. 3 upon 8. And this 5. Alright, this 5 is here into 5. Let me write down into 5. Alright, and 1 upon 5 is n minus 1. So when 5 goes up, it will become 1 minus n. Laws of indices from your class 9. Powers and exponents. Alright, so you can write on this into 5 raised to the power. How much? N minus 1, so 1 minus n. Alright, 1 minus n. Okay. And this 5 will go with this because the bases are same. Again, exponent, powers and exponent, laws of indices. So this gives you, this is equal to 3 upon 8 and 5 raised to the power into 5 is 1 plus 1 minus n, that means 2 minus n. 2 minus n. This is the answer. Is that fine? This should be the answer. In your book, the answer is given this, but you can simplify it till here. Alright? Okay? So, hope now it's clear how to find out nth term of a geometric progression or 4th term, 5th term, 6th term, 7th term, like that. Okay? Okay then. Thank you so much. Thanks.